I recently posted a video of the song Rush E being played in Chrome Music Lab's shared piano, and a lot of people asked me how I did it. Here, I'll explain my process of reverse engineering shared piano to play MIDI files. In case you don't know what shared piano is, Google has this fun website called Chrome Music Lab, with 14 different music-related experiments. The first one is called Shared Piano, and it's a piano that you can play online with your friends. For some reason, I decided I want to import MIDI files into the piano. Also, I want to be able to import any number of instrument parts, so I can load in full songs with percussion and several different instruments. First, I'll try saving some notes with the programming language Python. I need to find the HTTP request that gets sent when I press the Save button. My hope is that it will include some sort of save code for the notes I play. I'll play a note, go to the Network tab of Chrome DevTools, and press the Save button. This first request here looks like what I want, and it looks like the payload contains a save code. It's encoded in JSON format, which is nice and easy to work with. So, I'll copy this request in the curl format, so I can convert it to Python code using the website curlconverter.com. For projects like this, I like to write code in Google Colab, so I can easily test individual parts of my code. I'll start by writing some code to save whatever notes I want. First, I'll make it so I can edit the save code JSON using a Python dictionary. I noticed that the save code has a few parts. Notes is a list containing information about the notes. Elapsed is most likely the length of the song, although I'm not sure yet what the unit is. It's definitely not milliseconds or seconds, because my brief song that generated this save code was a couple seconds long. Users must be a map of the different users of the program to the instruments they're playing. My icon was a koala when I saved this song. I don't know what key map is exactly, but I'll deal with it later if I need to. Let me go back to this notes key again. If you've worked with MIDI before, you'll notice that this MIDI value is the MIDI number of the note, which tells the MIDI player which note to play. The other self-explanatory attributes of the note are color, velocity or volume, start time, and end time. This sustained value refers to the same effect a sustain pedal has on a piano. It isn't as clear what pitch and octave do in this case, so I'll leave their values alone until they cause a problem. That's everything for the save code part of this request. Outside of the save code, mostly everything looks pretty straightforward and not subject to change, although I noticed this name parameter in a couple places. It looks like it's the ID of the saved link that shows up in the URL hash, so I need to generate a random ID on each save, and it's just a string of letters, both lowercase and uppercase. Now, I'll add a middle C to the end and see if it saves correctly. Yay! All I have to do now is read through MIDI files and convert the notes to the savecode format. I won't go too much into the actual Python code for parsing the MIDI file, but I'll explain how it works. MIDI files are made up of different tracks, and each track is made of many messages that are assigned timestamps and signal different things. There are messages that can press or release a note, set the tempo, set the track name, and more. The timestamp of a message is not measured in seconds from the start of the song, it is measured in ticks from the previous message. Ticks are very short units of time that vary in length depending on the MIDI file. Ticks can be converted to seconds using the number of ticks per beat and the tempo. I will use the Python module mido to read the tracks of a MIDI file so I can process them. First, I'll iterate through the tracks and search for track name messages in each. There is a limited selection of instruments in Chrome Music Lab, so the program will ask the user to choose a Music Lab instrument as a substitute for each of the tracks, which could contain a wide variety of instruments unsupported by Chrome Music Lab. Finally, the program can go through the tracks one by one, converting the timestamps of note on and note off messages to timestamps in seconds. In the savecode JSON, the note on and note off times are used for the start and end values of the note objects, except they aren't. Remember how I noticed earlier that Chrome Music Lab measures times in strange units that are small fractions of a second but not milliseconds? After some experimentation, I realized that this unit must be a 60th of a second. I'm not entirely sure why, but it probably has to do with the fact that websites typically update at 60 FPS. One other thing to note is that note on MIDI messages include velocities, which are essentially volumes. These values I can plug into the velocity key of the Music Lab savecodes, which I mentioned earlier. After writing the savecode generator, it's time to test it. If you have any questions, please ask in the comments. Thank you for watching.